rush for spaces was due to portability between cloud service providers. So GoCloud. The aim of today's talk, and you might be thinking, is he just going to talk at us about portable cloud applications, read some slides, or give overly ambitious demos? The answer is yes to both. No, it's not really. Paul was worried for a minute. So what I really would like to do is to give you the tools to become productive with GoCloud today. So implicit in that is to understand what GoCloud actually is. What's the point of it? What's the problem it's trying to solve? And then we'll look at how it goes about doing it. There are some libraries and one specific tool that we'll use 2 demos to showcase. Before we dig into the meat of it, I thought it'd be worth covering why I love Go. I get to go first, so I get to say all these stock phrases. It's not just Rob Perk's excellent Paisley jacket, which I sadly couldn't source for this evening. So why I love Go. First one is its simplicity, and that doesn't mean that it's not going to let you do anything beyond the trivial, but that it's going to take care of the complexity for you. Go routines, garbage collection would be examples. And as I go through these examples, try and keep these in your mind as we go through the talk, as hopefully they're going to be traits of how GoCloud goes about solving its particular problem, which again we'll come to illustrate in a second. Productivity. So I'd worked with Java for a bit, as any good computer scientist of the mid-2000s did. And I was not being productive with that. Half-an-hour builds, that kind of thing. So that was a sort of serendipitous link to the origins of Go there. Then I moved to Node. So I thought, okay, I'll sacrifice type safety because I actually want to get something done at work. But then, there was that blog post from TJ Holloway-Chook from the Node community said, I'm ditching Node. I'm going to Go. So maybe I should as well. And so I did. And then I got that productivity back, but I retained that productivity, but also gained more productivity with the tooling and, in terms of my workflow. And portability as well. Unsurprisingly for GoCloud, portability is important. But portability, when I first came to Go, was pretty cool. Single statically linked binary is the output. Your deploy is SCP, at least in theory. So the structure of the talk, as I mentioned at the top, so we'll look at what the problem is, how GoCloud goes about solving the problem, and then live demos, plural. So this slide sums up what the problem is quite neatly, I think. So well I borrowed it from Eno Compton. So thanks to Eno, wherever he is. This was from a slide at Google Cloud Next 2018 in San Francisco, where I think it was the day after GoCloud was announced on the Go blog. So we can see on the right-hand side, we've got a nice blue set of lines. So we have our Go application that's decoupled from the underlying compute. The Go app's running in a container, orchestrated by Kubernetes, and then that talks to the compute, essentially. So we've successfully got this level, or 2 levels there of indirection. Let's say we're running on GCP, we say, okay, we want to move to AWS. Fine, nice and easy, because we've already got that level of indirection. But the problem we have, as you can see from the red arrows, is that we've got our GoCloud app, Go app running nicely in the container, but it's still reaching in via the SDKs or the APIs to vendor-specific, implementations or providers of those particular tools. So here we're reaching into a database. For the purposes of this tool, we can think about database as MySQL. Configuration, so it could be something like etcd or runtime configurator for GoCloud, then blob storage like S3 or GCS, Google Cloud Storage. So how does GoCloud go about solving the problem? You could probably guess. It adds a level of indirection at that level as well. So it's via 3 things. First is portable APIs. So that's providing a set of types, interfaces, and methods on those types, which encapsulate and describe these types of things at the bottom. So configuration, blob storage. As you Go developers out there will know, there's already one of those in the standard library in SQL.db, and we'll come on to how it fits into that. Cloud-specific definitions is the second thing it provides. So this is all the wiring functions that mean you don't have to interact with the auto-generated APIs that are based on the underlying SDK, the nitty-gritty. The third tool that it provides, which isn't on this diagram, but we will get to, is a tool called Wire, which allows you to wire up all of those things. So you haven't just replaced one problem with another. i.e. using Go Cloud's APIs in place of the specific Clouds SDKs. So let's have a look at what this actually, how do we actually use, what does it look like? So on the top right here, I've got the type that encapsulates the particular thing provided by the cloud service providers. Blob storage is the first. So if we're on Google Cloud Platform, this is how we'd go about getting it using one of those APIs that was mentioned on the previous slide. So we've got gcs-blob.openbucket, and again, those of you that are Go developers out there will recognize context. For those who don't know, this gives you a way of controlling your Go routines essentially. Then the bucket name, you open a bucket, you're probably going to have to give it a name. So the client, so you'll notice that some of these definitions do have vendor-specific parameters in them, but I'll come on to how that's ironed out for you in a second. And options is just key value pairs that are specific to that particular vendor. But crucially, we're seeing blob.bucket returned along with an error. Then we're on to S3. Very, very similar, as you can see. Again, there's a slight divergence in that we've got client.com provider instead of gcp.http client. But the key thing is that we're getting exactly the same thing returned, a blob.bucket. We can also use a local file if we want. Slightly different signature there, but again, it returns to you the same thing, blob.bucket with an error. Let's have a look at configuration quickly. So we've got runtime variable. Again, that's provided by Go Cloud. On GCP, so runtime configurator, we get it like this. Give it a resource name, sort of fully qualified path to the variable you want to watch. Decoder, that's quite a nice little feature where you can automatically unmarshal into the instance of a given type. Again, you've got options. Param store for AWS, so I'll just skip through these, but you can see you can use etcd support as well. And they all return to you a runtime var variable, which in turn has methods on it which you can use, decoupled from the underlying provider. And so I mentioned it earlier, but you might be thinking, okay, we know that, from one of Rob Pye's talks, the orthogonal components being one of the key aspects of Go's design. And you might be thinking, okay, Go Cloud's just going to come in and sort of nuke that and throw in a load of new types where we've already got a way of interfacing with SQL databases. So you'll be pleased to hear it doesn't. So for a database, a MySQL database, as I said, it uses the standard library SQL.db. And this slide's slightly different. So this starts to draw us towards Wire and how that comes in. So here I'm defining what a constructor for my application. And all I need to say is that my app needs a DB. We need a DB in order to create an app. Doesn't matter what else it needs. Then all we need to do in Go Cloud is to say how we actually get the credentials for connecting to that database. That's the only thing we need to do. And for AWS, we use RDS rather than Cloud SQL. Come on to how that actually works in a second. So that brings us on to Wire. So as you can see there, this was the bit where I said I was going to read from slides. So Wire is a code generation tool that automates connecting components using dependency injection. It's worth noting that Wire is, although it comes from the Go Cloud GitHub repository, it's not coupled to Go Cloud. It obviously resonates and works very well with it, but it's not coupled to it. So if you've got sort of dependency injection challenges, it could be worth checking out Wire, even if you don't particularly need Go Cloud. This is an example of how Wire works, at least at an abstract level. There are two key concepts, there are a few others, but two key ones when it comes to Wire. So the first one is providers. So we've got this dependency hierarchy, this dependency graph here. We can see that an app needs a DB, and that an app also needs blob storage. And you can see we've encoded that via this provider over here, like a constructor, but it calls them providers. Then a database requires config. You can see that from the provider here. I won't go through all of them. But you see how we've encoded that via providers. We then define the second key thing, which is injectors. An example of that's shown there. So this Wire is an example of code generation, as we said. So for those of you not familiar with Go, that sort of funny comment at the top there is a build tag. And what we actually write as injectors won't be included in the when we come to compile our Go binary. Instead, its output will be included, and we'll see that in the demo shortly. So you can see in the injector, I've called it inject, but you don't have to go with that kind of Hungarian notation. You can call it whatever you want. But you can see that it returns an application, and we use wire's inbuilt build function, and we give it a load of providers. So say, here are all the providers, work out all the dependencies for us, put them in order, and generate the body of this function. So when we run the wire CLI, we'll get a function out called inject_app, and the body of it will be all of the dependencies sorted out as per the providers that we gave it. Then at runtime, we just use the method, like that. So any excuse to use my favourite GIF, and at this stage I might need Paul to come and hold the mic for me. It might get weird. There we go. Showbiz. Cool. So for this demo, what I've got set up here, let's go full screen on this one. Is that big enough for everyone font-wise? Can you see that? I'll take that as a yes. Cool. So in my main app, rather than painfully watch me try and construct an HTTP server, I've done most of the boilerplate up front. And I've got two handlers here. So I've got an upload handler and a download handler. So you can see at the moment, this isn't going to be too much use in production, given when I upload a file, it just logs it and then returns nothing. The same for download. Up here, I've created a provider already. So I've got my application, and it requires a backend storage, a blob.bucket, again provided by GoCloud. So here's my provider for application, much like we saw in the previous slide. Not that one. That one. And so that's the provider there, the sort of top-level provider. So what we're going to do is we're going to write the injector, which is initially going to connect to GCP, to GCS, and it will allow us to upload an image, and then allow us to download it again. And then once we've got it wired up to GCP, we'll say, OK, we've had enough of GCP. We gave it 5 minutes. We're going to switch to AWS. So then we'll switch over to AWS. So first thing to do is just to create a new file, injectors.go. So as you saw in the previous slide, we're going to do build wire inject. And we'll do our injector. Oh, so let's use setup app this time, why not? And we're going to have to give it a context. As we saw earlier, pretty much everything requires a context. It's going to return an application and an error. So next we need to use that wire.build to actually make wire know about the providers that we're going to create. So we do wire.build. Then we just do GCP cloud.gcp. So this is a set of providers that GoCloud provides out the box for you to use. You can also group together providers into sets. So this is probably a sets of sets of sets, but it's all neatly grouped together. So the fact we want to use GCP, we just said, OK, we just want to use gcpcloud.gcp. So the next one we need to tell it about is new application, which was that constructor that we saw in the main.go. The next one, we actually need a means by which to get a handle on a bucket. So let's call that provide bucket. And obviously that doesn't exist yet. We'll do that in a sec. And then we can just have it, as long as whatever is returned from this stub essentially satisfies the signature up here, it doesn't actually matter, because as I said, the body of this function is going to be replaced when we run the wire tool in a second. So let's provide bucket. So provide bucket. Oops. First thing, context again. So that as we're going deeper into a nested Go routines, we've still got a handle into them. Then the next thing is gcp.http client. And we'll have it return a blob bucket and an error. And then what we return here is gcs blob.open bucket. Give it the context. Then we give it a bucket name, which I'll just shut up here. GoCloud demo 1. I've already set up the buckets just to save you watching me do that. So bucket name. We'll give it, would help if I gave that argument parameter a name. And then the final option for pretty much all of these is the options. So for this case, we don't have any options that we want to set, so we'll just set nil. So if by the magic of Go imports, I'll just write that. And you can see that it's brought in all these imports at the top. You'll notice that all of them are from GoCloud. So nothing that I've written is coming from the Google mono repo or anything like that. It's all coming from GoCloud. So if we just pop over to another pane over here, and we'll do wire. Sorry. Wait for the errors. Well, miraculous. Okay, let's have a look at what it's generated for us. So you can see it's a Git repo. So if I just do a Git status, you'll see that I've got the wiregen.go that's been created. So that's what I said before. Wire, well, in this case, injectors.go is the stub. Essentially, it's the definition of what we want. Wiregen is the output of wire that's going to have all of that stuff filled in for us. It's going to walk the dependency tree, work it all out for us. So let's have a look at it. Let's go full screen again. So there's the immutable comment at the top, the classic for all code generation. So here's the injectors from injectors.go. Get a nice little narrative as well, a little cheeky bonus there. So setup app, you can see that matches the signature for what we defined in our injector. But now, we didn't define you didn't define a variable called round tripper before. All of this has been injected. All we said was this bit down here. We said we need a gcp.http client, and that's all we did. GoCloud said, okay, because you need a gcp.http client, you also need all of this stuff. So you need the default transport, all this kind of stuff that I won't read out, you can see for yourself. But it's done all of that for us. It's taken away that heavy lifting and retained that, simplicity is complicated as way of doing things, as Rob Pike. So getting a lot of shout-outs today, Rob Pike, which is always good. So let's come out of there and actually we need to do one more thing, is to actually use the function in where we previously were just logging. So let's go into main. Got a couple of methods defined on application already for upload and download, just so that you didn't have to watch me do those. So first of all, let's use the function. So app, error, setup app. And then we're just going to give it a background context. If there's an error, we'll just return. Here we can just do return app.upload, f file name, app.download, file name. So now what we can do, we'll run wire again just for good measure. Then we'll compile it and run it. So let's build that there. And then we can just run the app. So first of all, let's upload it. I've got one of Ken Thompson here, one of the other Go creators. So let's upload that. And I should have done this first. Just got a GSUtil, so it's Go Cloud specific, but it's watching the files in Go in Google Cloud Storage GCS. So let's upload another one just to prove I wasn't cheating. Let's do one of Rob Pike. There he is again. Cool. So you can see that it's made its way into GCS. If we want to download that, let's do that. He's looking a bit stern there, but there we go. Cool. So we've both uploaded it and downloaded it using GCP via Go Cloud. So now we're thinking, okay, well, we've had enough of GCP. We're going to switch over to AWS. So what we need to do is to switch over to injectors again. And this is where Go Cloud really starts to shine. We've put in the investment of making this pretty much cloud agnostic. Yes, there are a couple of references to GCP in here. But we've made that effort up front, and you can see that wasn't too arduous. But now we want to switch over to AWS, we really get the benefit. So any guesses for this? There we go. Nice and logical. So we change this to S3 blob.openbucket. We then just change this, remember from what we saw earlier, to be client.config provider. And as you can see here, where we previously had GCP, we've done a sed GCP to AWS, and that's all good. This one does have a reference to the AWS SDK, but we didn't really have to think about it. It brought that in for us. So let's come out of that. So same process again. Let's run wire. And there we go. And we'll build that. While that's building, let's just see if I can split that as well. AWS S3. So we're just, this bottom tab, sorry, can't really, it's a bit smaller there, isn't it? But that's now going to be watching the equivalent bucket in S3. So we've built, so this time, AWS profile. So we're just going to run that same one, just with a couple of credentials, environment variables set there. And then we'll upload it again. So let's upload Rob Pike again, why not? So you can see that it's uploaded it, and we've successfully switched over to AWS from GCP. So let's pop back into the slides. It's probably worth staying there, Paul, because I'm on to the next demo in a sec. Cool. So that was the banker demo. Now it's where it gets exponentially less likely to succeed. So here we go. So armed with this, you know, we've decoupled ourselves from a given cloud, so let's use some of it to have a bit of fun. So this demo is going to, well, in theory, we'll have some fun. It might be fun for you, maybe not for me. We're going to look at the blob storage and the runtime var, so the ability to watch some configuration and react to it if it changes. So brief context to what the demo is actually going to do. So the first thing we're going to do is open up a browser tab. We're going to divide it into 60 by 60 squares, even though that says rectangles, and establish a connection to a backend. Nice and easy so far, hopefully. Then we'll say to the backend, we need, you know, X images to cover this screen. So we'll say we need that many images. That's going to go off to Meetup, you know, to our Meetup here, London Gophers, and get that many pictures from meetup.com. So I haven't done a speed check on fast.com, but I'm sure it'll be all right. We might be here for a while, as it painfully downloads them all. Then we're going to put it through another quite cool Go library, nothing to do with Go Cloud, but quite a cool Go library called Gift, which is an image filtering toolkit, as you can see. The reason why we need that is we're then going to put it into two backends. So we're going to put it to GCP, or GCS, or Google Cloud Storage, and AWS's S3. So the image filtering is going to put a kind of orangey, rusty hue on it for AWS S3 and a blue one for GCP, GCS. The app's also going to be listening to config. In this case, it's going to be GCP's runtime configurator. And the app's going to return based on the config. So the config's going to say what the split should be between S3 and GCP. And then once all the images have been loaded, we'll just send a message on that WebSocket connection, which will say, OK, just start loading. And it will randomly, pseudo-randomly start loading the images. As you can see, it doesn't say where it wants to get it from. It just says, give me image 22. The app will say, OK, let's just check where that should come from and get the appropriate image. And then why not? Because it's already so certain to succeed, we may as well add something else. We're going to change the config, but not just change the config. We'll go through a cloud function. Why not? And then we'll control the cloud function using Dialogflow. So it seemed like a good idea at the time. But let's pop over into some of the code just to show you some of the Go Cloud specific stuff. So this bit I've already written, you'll be pleased to hear. So setup app, hopefully you recognize that kind of idea, that injector from our first demo and from the slides earlier on. Got a slightly different returned structure here, our application. The func there is just a clear up function for some of the runtime config stuff, which we can ignore essentially. But wire.build, so it's that same special function, as it were. So we've got GCP and AWS running together. Application set, which contains our constructor, which I will show you that briefly, as it shows how you can create a set of these kind of things. I should have used there we are. Application. There we go. So you can see that's a pretty useless set. It's only got one thing in it, but you can extend them and then group together sets arbitrarily. And then we've got a couple of custom providers, which are in this function. So GCP splitvar is going to get a handle on runtime configurator variable. I'll update Docker later. There we go. And then, yeah, so as you can see here, we're using the client.new variable, which we saw in some of the early slides. This time we are using options, so we're going to poll every second for changes. And we're going to decode directly into a split config type. Clouds is the other one, and then we're good to go on the demo. So this one is going to return us a map of string to cloud, because why not? But that's pretty cool in of its own right. You can just have a cloud encapsulated in the Go type. But each cloud will have a blob storage, so blob.storage, as we've seen in pretty much all of the examples and demos so far. And it will also have this color, color definition in order so it knows what gift needs to set. And then we just put those in, so GCP and AWS. So let's give that a go. So there's a few things in there. Let's just wait for that to run. It's going to run wire, go build, so it's listing on 8080 now. So you can see that when the app starts, it just listens and say, what config am I currently set to? So let's say GCP 100, AWS 100. Sorry, AWS 0. So let's go localhost. Sorry, type localhost. So here's the portable cloud app demo. Got to fill the dead air as these spaces fill. So when those spaces all get filled up, it's then going to make the call to the back end, and it's going to then, at that point, start to go to meetup.com. And then, some fun things from meetup.com. They say they've all got a JPEG extension. Some of them are PNGs. So that was a fun one. And then it's only 20 results per page, so it's got to paginate through all of those, get the results. Then based on that, it's then got to run through the gift, the image filter. So, hopefully it's doing something in the background. Oh, there we are. Oh, ye of little faith. So, try and see if you can spot yourself on there. I promise it's from the London Gophers. I haven't just random pictures on the internet. So, as we saw earlier, well, actually it's gone now because it's given me some nice logging, but it's currently split to 100% GCP, 0% AWS. So we'll just wait for these to start or to finish loading. And we'll know when they finish because we'll start to see some flickering as it kind of redraws all the images. Because once it started loading, it's just going to keep going. It's not going to say I've finished, it's just going to keep going, so we'll end up in a cycle. Oh, there we go. So some of them are missing just because of, it's not the 100% robust, I'm sorry to say. But as you can see now, it's flicking through, so we're into the cycle. You will see those blobs gradually disappear. So I'll just use the dialog flow, well, I should say what dialog flow is really. So it's a way of creating chatbots provided on Google Cloud Platform, and you can deploy them to Slack or whatever you want really. And you can also deploy them to the Google Assistant. I have actually got my Google Home Mini with me, but I thought I'd just go with the simulator instead. So hopefully there might be some sound at this point in a second. Just fair warning. So you've got the dreaded on-call alert in the middle of the night, and obviously we're modern, and we're going to have AI chat-driven DevOps on-call rota, whatever we're going to call it. So the first thing to do is probably to talk to someone who knows what they're doing.
Get the test version of someone who knows what they're doing.
The test version is better than no one.
Must be on call or giving a I'm not sure which is worse.
Got this weird kind of vibrato going. Well, luckily you can all read it anyway, because that's the beauty of the simulator. So I'll say, how is the application configured? Let's see if that's going to do anything.
The app is currently distributed at 100% Google Cloud, 0% Amazon services.
Okay, Amazon Web Services. Cool, so that's all good. 100% Google Cloud, Amazon Web Services. Let's just pop over to here. So we've still got a nice sea of blue. So let's say, okay, obviously the logical conclusion with our image serving app is that Google's saturated. So we need to take some of the load off Google. We need to give a bit to AWS. So let's say route 50% to AWS and 50% to GCP. Just thinking about it.
Someone knows what they're doing isn't responding.
Ah, well, yeah, that's normally the case, isn't it? Let's try reloading. Someone who knows what they're doing, honestly. Okay, well, we're going to have to talk to them again, I'm afraid.
All right, get the test version of someone.
You might get to hear the cool spiel this time, anyway.
You must be on call or giving a I'm not sure which is worse. How can I put out the fire?
Okay, let's just cut straight to the chase. Route 50% to AWS, and 50% to GCP. Then, right, I'm going to try one more time with yeah, one more time with a different message this time. Okay, root. Obviously, a different number is going to work, isn't it? So, okay, well, let's see if I can quickly change it through here. Yeah. I probably can't. Oh, it did work. So thanks, Google, for the handy output there. Yeah, well, there you can see it. So it's changed the output. We've now got, hopefully that's roughly 50%. Someone hardcore AWS fan there with an avatar of AWS. But yeah, should we try one more, just as Google does seem to be helping us now. Let's say root 100% to AWS and 0% to GCP. Did it? No, it's gone back to normal. Cheers, Google, but at least one of them worked. So there we go. So I'll probably take a moment. So that's Go Cloud. Hopefully you've seen from that, you've now got the tools both, with the libraries, you've seen how it roughly works, you understand how Wire can take away the heavy lifting for you. And that's it. Just encourage you to experiment, have a play with it, come up with some, is that rating to 100? No, don't think it is. Have a look at some use cases for it. The one thing to mention is currently in alpha. I thought, shall I show people how to install it? But last time I did go get -u on it, it broke everything. So I didn't do that. So yeah, happy to talk through it in more detail afterwards. And that's me. Thank you.